Hello, what's up guys? So welcome to my new tutorial. So this tutorial is based on 7 segment display which is interfaced with the Raspberry Pi. So in this tutorial I'll be teaching you using 7 segment display how you can print even numbers, odd numbers and numbers from 0 to 9 on 7 segment using Raspberry Pi. So let's get started. We'll be using 1 kilo ohm resistors, 7 segment display, Raspberry Pi 4, breadboard and jumper wires. Okay. So starting from Raspberry Pi 4 and breadboard, so I have much more explained and detailed about Raspberry Pi 4 and breadboard in my earlier video, so you can go to that video and know more about it. So you can get it in the cards as well. You can see on the top. Then this is my 7 segment display. So there are two types of 7 segment display available. One is common cathode and another one is common anode. So to bifurcate between common cathode and common anode, so you can see the last two digit, the CC written over here. So CC means common cathode and CA means common anode. So we'll be using a common cathode 7 segment display for our project. So before going on to the circuit diagram, so let's see what is a 7 segment display and what are the hex value or for it, and how it is like 0 to 9 is displayed on 7 segment display. So you can see over here, this is a 7 segment display. This is the actual figure that you just saw before this, and these are the pin numbers, and you can see here it is A, B and C. So it represents like here the upper portion is pin number A, this is B, this is C, and these are the pin outs for this. So this is basically this thing which is shown over here. Now these are the pin numbers associated with this thing. So this is number 1, 2, 3, 4, 5, then this is 6, 7, 8, 9 and 10. Okay. So these are the pin numbers. Here we have two common pins. Now for displaying 0 on 7 segment display, so this won't be coming, right, and others are a high. So as told earlier as well, we are using a common cathode, so we'll be making this other digits as a high and the hex value will come out as a 3F. Now for one, B and C should be high. So we have done this, B and C as high, and the hex value for this is coming out to be 06. For 2, you can see as 2 as like this, then this, this, this and this. So A, B, G, E and D must be high. So this we have taken as high, and this is coming out to be hex value is 5e. Okay, so this way we have done all of this thing for each and every number, and here you can see the numbers as well, how it is like we're able to see on the 7 segment display. And we will be using this hex values in our coding part. so you will understand it in a better way at that time. So now coming on to the circuit diagram for this. So this is the circuit diagram. This is a 7 segment display that I explained you right now. This is the GPIO pins and of Raspberry Pi. These are the connection of this 7 segment display with Raspberry Pi. These are the GPIO pins of Raspberry Pi, and these are the pin numbers of on it. So now as you can see over here, we have connected A of 7 segment display at pin GPIO pin number 13. So here you can see GPIO pin number 13. Then for we have connected B at GPIO 6, and similarly we have connected C, D, E, F, G, and here we have left DP, which is the decimal point. So this is the decimal point on 7 segment display. So we have kept it as unconnected, and from both the common we have used number 3, and which is going to my pin number 39. So this is the whole connection of 7 segment display with Raspberry Pi. It is just as simple as that. So now let's see how you can connect it over breadboards. As shown in circuit diagram, so now we'll be mounting all the components on the breadboard. So we'll be connecting this 7 segment display in this fashion. So this point will be coming in downward direction, and will be connecting it across. You can see this is connected now. Now we'll be connecting resistors, 1 kilo ohm resistor over the point A, B, C, D, E, F and G. Okay, so this is how it is connected. So you can see over here we have connected all the resistors across this 7 segment display. Now as shown in the circuit diagram, we will be connecting this jumper wires with Raspberry Pi, and let's see how it looks. This is how it finally looks, and here our circuit diagram is now completed. Now let's move on to the code for writing the code. So coming on to the code part, so here we have imported rpi.gpio as GPIO. Then from time we have imported slip. So the slip will just basically shut the program for some time. So now we have made a setup function. In this, first we have written set warnings as false, so it will not show any warning at the beginning. Then we have made GPIO set mode as GPIO.bcm. After that we have initialized the pins as output. So these are the pins of 7 segment display. So for pin number A, B, C, D and going to F, made all these pins as GPIO.out. Now coming on to, okay, so I will come to this part later on. So first this is the loop that we have made. In this is the data. So this are the hex values of numbers starting from 0 till 9. Then I have made a while loop. So while true, what this will do, it will print all the even numbers first, then odd numbers, and then numbers from 0 to 9, and this will keep on rotating until any interrupt is given. So here we have written as for x in range 10. So these are the total 10 values. So here number 10. So x in range 10 if x percent 2 is equal to 0. So what this means is, so if you take this value, so this is a hex number of 0. So this will check with percent. This will do as 0% 2. Yes, it will be 0. Then this value will be stored in this pin, and then we are giving it to the function that we have made above here, the port function. And so what this will do is port. Okay, so port function, this value will come over here and it will check with 0x01. If it is true, then GPIO output of pin GPIO number 13 will be high, else it will be low. And this is done for all the pins. After that, after it is executed, so like it will print 0, 2, 4, 6 and 8. Then this will come out of the loop. Then we are keeping it sleep for 1.2. Then we are printing all the odd numbers. The code is same for this, just changes. Instead of equal to 0, we are putting as not equal to 0. After that, after completing all the odd numbers, we are printing all the numbers starting from 0 going till 9, and this will keep on rotating. Now I have made a if name equal to main function. So what this will do is, I will define all the functions that I have made above. I will be putting it in this loop, try and except loop. So what this will do is, first I have done all the setup part. So this will run only once. The setup is done. After that, try. So what this will do is, it will try this function until any keyboard interrupt. So what is keyboard interrupt? Here keyboard interrupt is Control C. So unless and until Control C is given, before that this loop will keep on executing, and at that when you are pressing Control C, this means that the interrupt is detected and it will call the destroy function. So what destroy function will do is, it will just clean up all our GPIOs. It will reset it basically. So this was the whole code. So as you have seen the code, now I'll be running it. So you can see here, first all the even numbers is printed, then all the odd numbers, and after that it will start from 0 and it will go till 9, and again after that it will start printing even numbers, and this loop will go on continuously till we give some interrupt to it. So thank you guys for listening to me, and I hope you like my video. So do comment and let me know how was the video. Thank you.